Recognizing patterns at the early childhood and elementary level helps children understand larger, more complicated concepts later on in their education. Because of this, music is often used to help children understand patterns sonically as well as visually. Unfortunately, there is a huge difference between aural patterns, meaning with your ear, and visual patterns. Let me explain. We've all seen visual patterns with shapes or colors. The ones you see in front of you are typical of the patterns we share with children. Sonic patterns, on the other hand, have a flow that's completely different from the flow of a visual pattern. Consider a limerick, which is yada da 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 da, or da yada da 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 yada da 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 yada da da yada da dum yada da 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 dum. The visual that you see in front of you has the pause, which is yada da 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 da, pause, yada da 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 da, pause, yada da 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 da, yada da 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 da, pause. To really understand a limerick, you have to get it in your ears. Children have to get it in their ears. We don't get it in our eyes. We get it in our ears. We understand it. Children understand the flow of a limerick aurally, not visually. You'll notice that I've highlighted the breaks or the cadences or the strong points of a limerick with the little stars or bursts. There are the 3 blue and the 2 red. And the rhyming scheme of a limerick is that the first 2 lines end with a rhyming word. The middle, or the 3rd line, that is, has an internal rhyme that rhymes with itself, and the last line rhymes with the first 2. It also has a certain gait. Bum bada bum bada bum bum. Bum bada bum bada bum bum. Now 2 short ones. Bum bada bum bum bada bum bum baya ba bada bum bum. Compare this with a rhymed couplet. As you can see in this example, we have 4 lines, and the first 2 lines end with a rhyming word, and the last 2 lines end with a rhyming word. Bum 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 bum. Yum bum 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 bum. Yum bum 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 ba yum. Bum ba yum bum bum. Because music and language share many commonalities, they're not the same thing, but they do share some common attributes. Let's look at what sonic patterns in music look like visually. We have 2 basic types of patterns, and what makes a pattern is the space of each section and the cadence. Cadences will always come at the end, just like we saw in literature, in poetry, in rhymes. It comes at the end. The 2 basic patterns in music are, as you can see here, AABA and AAAB. And the last A in the first line and the last B, or the only B, in the second line are the cadences. They represent the cadences. That looks fairly simple, although the structure of musical patterns is deeper than this. As an example, the pattern that we saw in the previous slide is only the superstructure. What music really is are sets and subsets, and this is why it's more like algebraic thinking than geometric thinking, or thinking about simple geometric patterns. It's algebraic in that there's a lot of variability involved. Each section, whether A or B, is composed of smaller subsets of sounds. Each A section may take 30 seconds to. Looking at the middle of this slide, you can see that the larger A can be enlarged, and we can see that what looks like one thing really is a combination of many other things, and that A pattern has a smaller A pattern within it. It is also AABA, and that the smaller A section, which we in music use a lowercase a to denote that it is not the big structure, it's the smaller subset, that smaller A can vary itself. So within each larger section, there is another pattern embedded in it that can vary. And in this particular example, you can see that there are two things in every smaller section that can vary. Even though I've used an AABA pattern as the subset of the larger A in this particular example, it could have been an AAAB pattern. Regardless of which one it is, it's always going to be one of those two, most likely. In all likelihood, it's going to be one of those two. One last thing that's very, very important about musical patterns is that they are symmetric. Musical patterns are symmetric. When you get down to the smallest unit, the smallest subset, it is going to be symmetric. You are never going to have one. You're always going to have at least two. And if symmetry is important, then there are going to be two here, two there. And if you have four here, you're going to have four there. Music grows exponentially. It doesn't grow linearly, it grows exponentially. Here I try to help you understand a little bit more about the symmetry of music. Music is often called antecedent consequence or question and answer. It's always going to have two. And as you can see in the top of this slide, the question could be 2 beats or 4 seconds long. And the answer is going to be exactly the same length of time, because time is important. Space and time are the thing that makes music music. It takes time. So if I have an antecedent of 4 seconds or 2 beats, I'm going to have an answer of 2 beats. And as you can see in the bottom here, I've notated an AABA pattern with colored lines, and that is the larger A. We have 1, 2, 3, 4 questions and 4 answers. Because we can't have 3. We can't have 1, we can't have 5. It has to be 2, 4, 8, 16. 32, 64. Music grows exponentially. So we have 4 questions and 4 answers. And note that the B part of the larger A has 2 different colors, indicating that there is different sounding music. The thing to take away from this is that whatever the larger A section is or the smaller A section is determines what all of the following sections are going to be. If the first A section is 10 seconds long in this example, 10 seconds long for that smaller A, then the next smaller A is 10 seconds, the next B is 10 seconds, the last A is 10 seconds, so that one section of the larger picture, meaning the larger AABA, that one section is 40 seconds. And if that section is 40 seconds, it dictates that the next section, the larger A, is 40 seconds. The larger B is 40 seconds, and the final A is 40 seconds, meaning all 4 sections put together, the entire composition, when you press play till you press stop, is going to be 40 plus 40 plus 40 plus 40. 160 seconds in total length. The last thing I want to state and reinforce is that each of your sections, be they a small a or a large a, every one of those A sections has to be identical. Identical. If you create an A section and you put another A section behind it, after it, it has to sound exactly the same. Exactly the same. At least at this point in your understanding of what musical patterns are. Music grows exponentially. We have 2, then we have 4, then we have 8, then we have 16, then we have 32, and so on and so on. It grows exponentially, and that the 2 basic patterns are, for a composition or a smaller musical phrase, are A, B, A, or A, B. When you can manipulate musical patterns and vary their length and let them grow exponentially, then you are well on your way to understanding the basics of music.